Welcome everyone to the Tao Salon, our special session where we get into the zone with statistics. Today we're going to talk about something we all do every single day without even thinking about it: measurement. From rating a product online to checking the weather, we're constantly slapping numbers onto things. But have you ever really stopped and asked yourself what we're actually doing?
So let's just jump right in with a question that seems super simple on the surface, but it's actually incredibly deep. Can you put a number on something like loudness? Or how about happiness? Can you really measure a human sensation? I mean, we do it all the time, right? With surveys and star ratings. But is that real? Is it legit measurement? Well, believe it or not, this exact question completely stumped a whole committee of the smartest scientists from the British Association for the Advancement of Science. And they didn't just kick it around for an afternoon meeting. Oh no. They argued about this for 7 full years.
So what was the big holdup? Why were these brilliant minds stuck spinning their wheels for nearly a decade? Well, here's the crazy part. Their problem wasn't even the tricky nature of human feelings. It was way more fundamental than that. They couldn't even agree on what the word measurement meant. Without a common definition, they were just talking past each other.
And then along comes this psychologist, S.S. Stevens, in 1946, and he just cuts through all that debate with this one beautifully simple idea. He basically said, look, measurement is nothing more than assigning numbers, but you have to do it according to some rules. That's it. It's not some cosmic truth, it's just about the rule book we decide to use.
And that right there is the idea that changes everything. This is the absolute key. Because the kind of rule you choose, well, that determines the kind of measurement you're actually doing. This one thought completely reframes the problem and turns that 7-year-long argument into a crystal-clear system.
So, Stevens' simple definition gives us this fantastic framework: 4 different scales of measurement. Each one plays by a slightly different set of rules. This table here is our roadmap for the next few minutes. So let's dive in and break down what each of these really means.
All right, let's dig into these 4 scales of data. Getting a handle on these is seriously the first step to becoming way smarter about how you look at statistics and all the claims that people try to make with them.
First up, we've got the nominal scale. This is the most basic one you can get. The best way to think about it is that the numbers are just labels. That's it. Think about a player's jersey number. Is the player with number 10 twice as good as the player with number 5? Of course not. The number is just a name, a way to tell them apart. You can't do any real math here, except maybe count them.
Okay, next level up is the ordinal scale. Now, the order starts to matter. Movie ratings are a perfect example. We all know a 5-star movie is supposed to be better than a 4-star movie, but how much better? Is the gap in quality between a 4 and a 5 the same as the gap between a 1 and a 2? We have no idea. Ordinal gives you the rank, but it tells you nothing about the distance between those ranks.
Now we're getting somewhere. Number 3 is the interval scale. And here, the steps between the numbers are finally equal and meaningful. The classic example is temperature in Celsius. The difference between 10 and 20 degrees is the exact same amount of energy as the difference between 20 and 30. But there's a catch, and it's a big one. 0 is totally arbitrary. 0 degrees Celsius doesn't mean no heat. It's just the point we picked for when water freezes.
And finally, we arrive at the most powerful scale of all, the ratio scale. What's its superpower? It has a true, meaningful 0. A true 0 means the complete absence of whatever you're measuring. Think about the money in your wallet, or your height, or your weight. $0 means you have no money. And because of that true 0, we can finally make ratios. We can say with 100% confidence that $20 is twice as much as $10.
Okay, so we've got these 4 different scales of data. But why does any of this really matter? Here's why. The type of scale you're working with strictly dictates what kind of math you're allowed to do on it. If you use the wrong math for the job, you don't just get a wrong answer, you get an answer that is complete and utter nonsense.
And this is where the rubber really hits the road. You can avoid so many common statistical traps. For instance, if someone told you the average jersey number on a soccer team was 14.2, you'd know that's a meaningless statistic. And you'd also know that claiming a 5-star product is 25% better than a 4-star one is just marketing fluff. You can say it's better, but you can't put a percentage on it. Knowing the scale is like having a built-in nonsense detector.
So let's bring this all home. How can this academic debate from the 1940s give you a real practical edge in your work today, whether you're in business, marketing, or research? Well, I think we can boil it all down to 3 incredibly powerful takeaways.
Here it is.
A simple 3-step mental checklist. First, all data has a type. Before you do a single calculation, you have to ask yourself, is this nominal, ordinal, interval, or ratio? Second, the type sets the rules. That scale tells you exactly which mathematical operations are valid and which are not. And third, and this is the most important, if you break the rules, you break your analysis. Your whole conclusion, your A/B test, your big report, it all becomes worthless.
And I'm not exaggerating when I say this is a superpower. When you get this, you start seeing the world differently. You can look at a customer satisfaction survey and question if they're averaging ordinal data. You can build marketing claims that are not only powerful, but also honest. You'll be the person in the meeting who spots the flaw in an A/B test, helping your team make genuinely smarter business decisions. So I'll leave you with this one final thought. The next time you see a chart, a news report, an ad, and it throws a number at you, what's the very first question that's going to pop into your head? If you find yourself thinking, wait a minute, what kind of data is that? Then congratulations, you've just unlocked a whole new level of thinking.